It's so important because I believe the architect and the engineer of the future is going to be more of a hybrid. Like today, you can't be an architect and engineer if you don't know how to use software.
Hello, and welcome to a new episode of Cup Talk. My name is Jörg Lantzsch, and in this podcast we are talking about computer-aided design, software, hardware, actual technology, and future developments. Today we have quite a special guest from NVIDIA, which is one of the largest companies worldwide in terms of market capitalization. For the last 3 decades, the company is a technology leader in graphics computing, and during the last years in artificial intelligence. I think mainly all hardware comes from NVIDIA when it comes to artificial intelligence. Today, our guest is Jean Yang, Director AECO Geospatial and AI Solutions Industry Marketing. Hi, Jean.
Hi, how are you?
I'm fine, thank you. Complicated job title or long job title.
There's a lot to do.
Okay. Also, most of our listeners may own even some stocks from your company. Probably we start with a short introduction of NVIDIA, especially the development from graphics computing towards artificial intelligence during the last years is, well, in my opinion, it's a very interesting journey. Perhaps you give us a short overview.
Yeah, sure thing. So if everybody's familiar with the CPU, and that's the computer that manages the operating system of your, that's the processor, I should say, that manages the operating system of your computer, of your phones and tablets and all those things. And the CPU is really good as a general purpose processor. So it manages the operating system. It could have a couple of applications running, but it's not very good as an accelerator to make things go super fast. And the reason is that the CPU only has a finite number of cores. Like usually on your desktop computer, you have like, let's say 10 cores. One core runs the operating system, one core runs Revit, one core runs Outlook, so on and so forth. And Revit can then go and take another core if it needs for things that it can parallelize. And parallel computing means it could break something down into smaller parts and compute it in parallel. And the more parts you could break it down to, the more parallel processing you could do, the faster it goes. Because instead of doing one monolithic task, you're breaking it down into lots of small things and parallelizing it. So NVIDIA realized back in 1993 that for certain workloads, the CPU limited cores just didn't accommodate tasks that can be parallelized, like graphics for video games. Those graphics need to go in real time. So timing is of the essence. And to make it go fast, you take the graphic and break it apart into lots of small parts, each of which goes into a core. The GPU has, instead of like a dozen cores, it has thousands and thousands of cores. And you could attach many GPUs together into one computer, and you get more and more cores without degrading performance. To make it easier, this is all meant for software developers. NVIDIA is a company that makes tools, software and hardware, for software developers. So to make it easier for software developers to accelerate their software on the GPU, NVIDIA made a programming interface called CUDA, C-U-D-A, which is a set of libraries that any software developer could use to tap into the power of the GPU. And we work with just about every software developer in AEC space to do this, to accelerate certain elements of their software applications.
So let's talk a little bit about your role within the company. I mentioned the very long title. So perhaps a bit of your personal background, where you started within the company and how you developed and what you do actually from day to day. Besides of recording podcasts, of course.
Yeah, I've had many jobs at NVIDIA and many jobs over my career, most always focused on computer graphics in product management, marketing, business development. At NVIDIA, I've been focused on those things for the manufacturing and automotive industry, for AEC and geospatial industries, focused on our technologies like Omniverse and RTX, and now more than anything, AI. And on a day-to-day basis, I'm talking with customers, partners, and the community at large to share knowledge about what NVIDIA is doing in terms of the technology innovation, how those technologies can be leveraged in terms of enabling use cases, and helping our partners communicate these values out to the community.
I was surprised when I first read its AECO. Usually we talk about AEC, industry, architecture, engineering, and construction. Within NVIDIA, you talk about AECO. What does the O stand for, and why is it different to the, let's say, rest of the industry?
Yeah, the O is really important because it stands for operations. So that's building or asset lifecycle operations. So as we think about digital twins, which is powered by AI and generate the capability for AI to do its thing, those digital twins really matter in the operational lifecycle. So if you think about typical AEC, you have a couple years. A couple short years, you design and simulate and visualize your project. You build the project, so the AEC. But that only lasts a couple of years. The O lasts for a long, long time. If you're building a bridge, that's going to last a long time. So, we have this mentality in AEC that, the A and the E, you drop off the construction documents, the C builds it, and then, not our problem anymore. It goes over to the owner developer. Well, I think there's a change coming. And that change is going to be informed by some of the technologies that are disrupting our industry, AI and digital twins. And the truth is, we can make much better designs by having engineering or physics-informed designs. But how do you get rewarded for those designs, and how do you determine if the designs are better? It's not from aesthetics. I mean, that's the measure that we've been using for a long time. Thomas Heatherwick has the boringometer, is the aesthetic boring or not? And that's true, that matters for our built environment. But what matters possibly even more is does the design work in terms of what it's designed to do? How's humans transport cars across water, support the infrastructure in terms of the water and sewage of our cities? How do you determine, and how does the designer and engineer get rewarded for successful designs in terms of KPI? All of that comes out to play in the operations, which is the life cycle and perpetuity of the life cycle. And digital twins help operators manage, observe, assess, and troubleshoot, and improve the assets and buildings that they're operating. The operations, I believe, we think about it as a separate thing. It needs to play back in, because I know from talking to designers and engineers that they're really starting to think about how to form longer-term alliances with the developers so that they could be rewarded for creating buildings that work, not just that look good.
You mentioned just a bit in the beginning that graphics computing played a big role in computer gaming industry. That's where I knew NVIDIA from. Not that I'm gaming myself, but my kids. And they needed the newest graphics card for their computer that the games run very fast and smooth. And you told me in the previous conversation we had that AECO was an important market for NVIDIA right from the beginning. Is this true, or do you started from in the gaming sector and then switched over to AECO?
Well, the GPU originally was created for gaming, for gaming that required graphics to be displayed in real time. This is in 1993, so we're back in the earlier days of CAD and 2D graphics that still had a graphics viewport, but maybe less computationally intensive. That quickly started to evolve into 3D graphics, which are computationally more intensive. And that's when the GPU started to matter to a broad number of users outside of gaming for 3D graphics. in AEC, in manufacturing, in media and entertainment, not just for games, for movies and such. So if you think about like every BIM and 3D CAD application that your listeners are using, those to have a good viewport experience when you're moving around, doing a walkthrough, looking at shaded surfaces with trying to get a realistic sense of lighting, etc. All of that is powered by the GPU. So that's why NVIDIA has been in the AEC industry providing GPUs for that visual display capability of the CAD and 3D software for a long time. But it turns out that those GPU cores that I was talking about that are, originally for graphics are actually good for a lot of other things. Mathematical computation like engineering simulation, lighting simulation like ray tracing, and of course, AI, what is really the key focus of NVIDIA today.
Yeah, let's talk a little bit about AI. When ChatGPT became, let's say, available to everybody, for the public, it was quite surprising, the large language model. And so language and graphics is a sort of a different thing, but it's a lot of computing power you need, right? And that's where your hardware comes into the play, yeah?
Yeah, well, so if you think about something like ChatGPT, one of the reasons why it's so effective is because of the way it was trained. So AI is only as good as the way it was taught. It's like a child, a child can do amazing things, but the child has to be taught. And there's a teaching methodology, which is a bit of the science and the technical wizardry of these AI companies. But maybe even more importantly, there's the data that's used to teach, the historical data that we provide to our children to learn history. So ChatGPT was trained on the entirety of the internet. That is a lot of data. And that is, in a sense, the power of AI. And the reason why ChatGPT happened at this moment is because for the first time in our history, thanks to NVIDIA's technologies, companies like ChatGPT now have the ability, i.e. the power, the computational power, to train AI models on a vast amount of data in a reasonable time period. And this is why ChatGPT has, deployed so many GPUs, and we see these other companies that are doing similar things, building AI, what we call AI factories, which are data centers with lots of GPUs. And this is because the computational power needed to train is a lot, because the training data is a lot. So, but don't confuse the training with the inference. Training is studying all of this data. You need, let's say, hundreds of thousands of GPUs for a very large language model like ChatGPT, but the inference can run actually on a single GPU. You take that model, if it fits in the memory of a single GPU, after the model's trained and made, it can run on your laptop, in theory, depending on the size of the model.
You gave quite an interesting talk in the paper. I read the paper, but it was always also a presentation you gave about, I can't remember the title, but I will put the link in the show notes. It's how to get started with digital twins and AI, right? Mm-hmm. Can you talk a little bit about this?
Yeah, well, what's interesting is when CAD came to us, we were using blueprints. It was really we were drawing by hand with rulers and doing engineering with slide rules. We didn't know anything about computers, and we learned computers as not because of interest in computers, because we had to get a computer for CAD, and the choices were very limited. There weren't like computer scientists and stuff that we can go hire from school, and we weren't about to do that because everything we can do was dictated by the software we were using, like AutoCAD. The world is very, very different now, but the disruption that AI is about to unleash is profoundly, at least as impactful as the invention of computers and CAD. if not much, much more so. And one of the reasons why is because we've evolved. We all know computers. Our kids can type Python, in high school. So we have the power to do things independently. And keep in mind that AI can write software. So there's not the same dependence on a very small number of companies to determine how we work. I'll give you an example. Tim Fu Studios in London, they are inventing the way they work by writing their own software with generative AI. Their entire design process is based on AI. They're not using off-the-shelf software tools from the big software vendors. And they think that's their competitive advantage. They're a very small firm, but they're competing on very large projects with very large competitors. So now, what we're seeing in the landscape is, yes, you have the traditional ISVs that are quickly incorporating AI into their solutions. Then you have this vast number of, I don't think anybody has ever seen anything like this in AEC, this vast montage of startups across every use case. And there's a VC community in making investments in these companies, and they're doing incredible things based on AI. And then we're starting to see internal in-house software development. We've seen in-house software development in AEC, like with, Grasshopper scripting and Revit customization and stuff, but it's at a whole new level now. And one of the reasons for that is because the power of AI, as I mentioned before, comes from the training data. And every AEC firm has decades, if not over 100 years of training data from all the work they've ever done, which is sitting in their hard drive. So if an AI can be exposed to that data and learn the way a company does quoting, scheduling, design, floor planning, learn the secret sauce in the ways they do their business, then that company can become just so much more productive. And this is why I'm starting to see, and this is maybe the major disruptive force, is that companies are hiring software developers to write their own AI software to tap into the vast amounts of data they have in their hard drives.
So would this mean that a typical architectural firm would need less architects, engineers in the future, but more software developers?
I don't know.
And what would it mean for the software vendors if everybody writes the software on its own or the AI is doing it?
Yeah, so I'll start with the first part. I don't know that it means fewer architects or engineers. I think it means a different type. And my kids are in engineering school, and I am encouraging them all the time to develop an aptitude for AI, because I believe, and in one of my kids' schools in the curriculum, they actually are teaching AI and Python. It's so important because I believe the architect and the engineer of the future is going to be more of a hybrid. Like today, you can't be an architect and engineer if you don't know how to use software, AutoCAD and Revit and MicroStation and all. Tomorrow, you can't be a successful architect and engineer if you don't know AI. And so I think, software developers aren't going to replace engineers, but engineers who know AI might replace engineers who don't. So I think that's going to be the challenge, is how do you bring AI? How do you how do you tap into the software tools you have today to be more productive with your work? In the future, it's going to be, how do you tap into AI to be more productive? And there's a lot of creativity involved in that process, because every day there's something new coming out of the sky with AI, and we could expect some significant disruptions to the degree of ChatGPT in the future for a while in the category of AI. And this doesn't change things for the ISVs, because not every firm is going to have the interest or the resources to have their own in-house software development. I think the ISVs are going to need to figure out a way to enable their customers to tap into their own data without providing it to the ISVs because it's proprietary or secure or whatever, to find what's called fine-tune or customize AIs. So the ISVs can provide sort of like this baseline. This is how the feature works. And now using your own data, you can customize it to do things your own way. And so that's a process that's going to have to play out. Keep in mind, the ISVs have software that is, in some cases, decades old, many million lines of code. So adapting it to AI is not so easy. It's just, throwing AI in it. That's why we're starting to see a lot of startups who are developing software from scratch that is AI-centric.
Okay, good. So outlook into the future, that's usually my last question in the podcast. When you said, you told me your kids are in engineering school, what will their day-to-day work look like, let's say, in 10 to 20 years, when I'm already retired?
Yeah, I mean, I see it today. I have a kid who's interning in civil engineering, and the tasks are completely mundane. It's like drawing lines for curbs and road markings and stuff like that. Things that an AI can do, where like literally he's adding none of the intellectual value and skills that he's developed in his studies. No creativity. AI is going to eliminate, in my opinion, those tedious jobs. It's going to eliminate the tediousness of our work, enable us to focus on things that tap into human creativity, ingenuity, and allow us to create things that we just don't have time to create. It's going to allow more iteration. It's going to allow more time to focus on the nuances and the small details of things, more time for communication, and perhaps most importantly, the gradual elimination of errors that are caused by miscommunication, lack of time, oversight, too many file formats, too many documents that aren't compatible, it's too much confusion on the job site. That's going to go away.
Okay. Thanks a lot. Interesting outlook. So thank you, Sean. It was a very interesting conversation.
Thank you very much.
So to our listeners, I hope you enjoyed this episode. I'm always open to your criticism. Let me know what you like and what you don't like, what we can improve, and probably who we should invite in the future and what we should talk about. Easiest way is to send me an email or contact me on LinkedIn. And for the last favor you could do me is click now on the subscribe or follow button on your podcast player so you won't miss the next episode of Cut Talk. For today, I say goodbye and until next month.